Hello everyone, I will be showing you the speedometer functionality of my project today. Just be aware that you need to be in a safe environment and not to operate cell phones while you're driving. We'll begin. Currently I am at 0 miles per hour. The screen is showing a little bit of movement due to the GPS movement and the satellite movement, but it should overall be pretty accurate. I'm going to rev up here to about 10 miles an hour. As you can see, it's matching it pretty well. We have 9.5. My speedometer is showing 10, about 9.8. So just keeping track of it really well. If I rev it up to about 15 miles per hour, as you can see, also the speedometer keeps up really well. There's a little bit of interference, of course, with the satellites moving around. So it's kind of difficult to track your location constantly, and the Raspberry Pi refresh rate isn't able to keep up with it too well. As you can see, I revved up here to 20 miles per hour, and the speedometer is showing about 20 miles per hour. So I'm going to slow down here to about 0, and as you can see, it's definitely decreasing. What I'm going to do is I'm going to show you guys the distant aspect of it, just to show you how much distance I've covered. Oops, those are stuff from the points. Looks like there's a bug with the distance. So I reset the distance. I'm going to travel a little bit here, and you're gonna see the movement. Let me wait for this individual. Okay, so I'm traveling now. As you can see, it's definitely tracking movement. In order to get my distance from coordinate to coordinate on a GPS system, I'm using something called Haversine's formula, and that actually takes the roundness of the Earth into consideration when discussing your distance. It's very useful, especially for long-term GPS movements. In my application, for some reason, I always get a little bit of distance that just accumulates over time, and it just keeps compounding and compounding. That's why you can see that this number keeps shooting up, even though I'm moving relatively slowly. I haven't really moved 4 miles. It's been more around 2 miles, and I'm gonna stop right here and slow down. And you see, it just kind of stopped right there. So I'm also going to reset it. You can reset it with the button out here on the left. Let me go back to speed so I can show you my speed. So I'm currently stopped, so you can see it's slowing down. And one of the cool functionalities of this is the GPS is constantly tracking your location. It's constantly shooting out data over the UART. The issue that happens if it gets hung up or if it stops for any single moment, then the rest of the system slows down because it's waiting for it. In order to kind of get around that, I've included a few kind of catches for errors that should be able to catch it. The only issue is the Raspberry Pi is still a little too slow for this sort of application. Definitely next time I will implement it on a different microcontroller so I can get a little more speed. But I think above all, everything works okay. Thank you guys.